Hello students, welcome to this brand new chapter. I'm really happy that you have come this far. Now let's move into the programming side of it. In this chapter we'll learn about the Arduino programming from the very basics.
At a very high level, we should first understand how this all works. In case of computer programming, our programs usually run on a computer. However, now we are going to learn to program our microcontrollers. We will write our programs in Arduino IDE and connect our boards with the computer to upload the program into the microcontroller. Now let's deep dive into the programming part of it. So if you see here in the Arduino website, under documentations header, you have reference section, which is the documentation of all the functionalities available in the program. I'll now open Arduino IDE. When you open this IDE, it comes up with a blank sketch. It has two basic functions. One is the initialization part of it, which is function called setup, and another one is called loop. It is the execution part of it. This is very similar to C and C++. Arduino is basically based on a programming called processing, but their syntaxes are very similar to C++. Now let's understand the parts of programming. Here, language is categorized into three sections. One is functions, another is variables and constants, and then third is the structure side of it. We'll look into a few of each section. Now, the first most important one that I think is pin mode. Let's see what it is. So if you go into this function documentation, it will tell you each and every detail about this function, like this, what is the syntax, what are the parameters, and an example code as well. So this function pin mode actually is used to set the pin as an input or as an out. So you're initializing your pin as an input or output basically. Whenever you have to interact with a pin, means you either have to read a signal coming into a pin, then it will become a input pin. And whenever you have to give a output of that pin on that pin, then it becomes an output pin for you. And in the programming, you have to define that whether it is a input pin or a output pin, and it is done using this particular function. Now, this is the syntax. You will give the pin number and the mode. Over here, the mode is input or output. Then let's look at the other functions, like in digital input output. Digital read is the function used to get the values coming in at a particular pin. So let's go and see what it is. So let's say you have assigned a pin mode to particular pin number and you want to get the value coming in. So you can use this function digital read and provide the pin number. The output of this function would be either high or low. If you remember, then digital signals are either 0 or 1. So 1 represents high and 0 represents low. So you will get the output as 0 or 1 or high or low in constant format. Similarly, let's go to the other digital write function. So digital write similarly will write 0 or 1, which is high or low at a particular pin if you have assigned pin mode as output. Then let's come to analog input output. So if you want to read analog value, then you can read the voltages in a format such that it divides that voltage from 0 to, let's say, 5 volt into a range based on the maximum resolution of that particular board. So if you are using Uno board where the operating voltage is 5 volts and you are reading input from analog read pins, which is from A0 to A5, then the maximum resolution is 10 bits. which means your analog to digital converter will give you an output and transform the input voltage into 10-bit of value. So that means 2 to the power 10 is what you can expect. Means 0 volt till 5 volt will be translated to 0 to 2 to the power 10. 2 to the power 10 is 1024 basically. That means if you include 0, then from 0 till 1023 is what you can expect in your as the output of this function. There are some boards which support 12-bit of ADC, which means you can then in that case expect an output from 0 to 4095 numbers. So overall it means if you are providing a voltage at an analog pin and you want to read it in your program, then you can have a program something like this, where you define an analog pin, let's say it is A3, then you have a variable just to keep track of the number, and then you have a setup function which is like a constructor in C. It always executes first, where we'll do all the setup part of it, or initializations primarily. Then we are starting a new function we're calling serial.begin. We'll come to it what this thing is. Then your loop functions gets triggered once the setup is finished. So loop, as you understand, it will continue to run till the time your microcontroller is up. So in the value, we are reading the analog read pin, which is pin number A3. So any voltage on A3 pin will be translated to a value which will be something between 0 to 1023 if in case of 10 and Arduino. So if you are, let's say, providing 5 volts, so this function will give you 1023 in the value, and if you are providing 0 volts at A3, then you will receive a zero number, which is the digital representation of these input values. Let's see what other functions do we have. Then there are many, and I would really recommend that you go through each of them one by one because they will be really helpful in programming. Then maybe I can talk a bit about a few more commonly used functions. Like in time section, you see there is a function called delay. This pauses the execution for specified number of milliseconds. Then the millis function gives the milliseconds since the chip has started executing or run. Then there are math functions, trigonometric functions, and many more. In fact, you can go through them at later stages. I'll quickly move on to the variable section, where these are the constant values that represent something or the other in Arduino programming. Like for example, high would represent 1 in digital and 5 volts in analog signal. So if your board is a 3.3 volt board, then high would represent 3.3 volts and digital 1. Similarly, low stands for 0. In case of pin mode function, these are the constant that you provide as a parameter. Input means that pin mode will set the specific pin number to input mode, and output will set it to output. There is similarly one mode called pin input pull-up. Atmel microcontrollers have internal pull-up resistors that are connected, and you can access them using this constant. Similarly, on data types, if you see, then it has int, double, character, long, short, byte, all the regular data types which were available in C or C++, plus few more specific for. Then there are structural functions that are specific to Arduino coding, and these two are the most important ones, and I talked about them a bit previously as well. Setup is like a constructor which will always get triggered when your microcontroller is starting, And once setup function has completed, thereafter loop function will run infinitely, and all your execution or your programs should be written in the loop function. Then you have control structures, same logics that you would have seen in C or other programmings. You can glance through them, and there are other operators as well which come handy in your programming. So basically, these are the building blocks of Arduino programming that you should know, and I would really recommend that you glance through them and understand them, and spend some time to understand at least those which are commonly used, so that you can understand and write the programs efficiently. However, if you have programmed previously, then these should look very similar and familiar to you. A lot of new features can be added to your programming using libraries. As you know, that the libraries are the extra packages that allows you to do multiple new things with your sensors, with your different features within the Arduino. So for example, you want to use the hard disk of your Uno, which is called the EPROM, to store data permanently into your Uno. So you can utilize this EPROM library, which already has written functions to read, write, update, get, and so forth. It has all the features that you would require to work with EPROM in your Arduino Uno, per se. Similarly, there are multiple standard libraries, plus there are tons of libraries available from different developers across the globe. So for example, if you have new sensor available in the market and you want to use it, so you will certainly find one or the other library developed by somebody which you can directly use in your program instead of writing everything from the scratch. So in nutshell, libraries make your life much easier, I would say. This brings us to the end of current lesson. In the next one, we will write our first program and blink our LED. Exciting, right? So, see you in the next lesson.